Welcome everyone, and thank you for joining us today. This webinar and the slides will be available shortly after we finish on our website. We will have time for a short Q&A at the end of the presentation. You can enter your questions for the panelists in the questions panel of your GoToWebinar window. Now, I'll pass it over to our presenters, Damien Curry, Global Partner Engineer Director at NGINX, and Monica Miller, Senior Solutions Engineer at NS1.
Hey, good morning, everyone. This is Damien Curry with NGINX, and I'm joined, as we just said, with by Monica Miller here from NS1.
Hey guys, how's it going? Great to have all you with us.
Yeah, it's always good to talk to Monica again. We've been a couple months since we gave this presentation before, but hopefully we'll go just as well as last time.
Definitely. Had a really good time meeting all of you that were in attendance at the NGINX conference in Seattle back in September. Had a lot of great questions as a follow-up, so hopefully today we'll be able to help you guys out and answer some of those for you. All right.
Yeah, great.
Should we do this? Are we ready, Damien?
Yeah, might as well get this going.
All right, cool, awesome. So let's just do a little bit of housekeeping and maybe start with a light agenda and kind of talking about what we're doing here today. I think one of the things that we want to educate you on at NS1 is some of the different ways that we do GSLB and how we complement NGINX Plus, and also talk a little bit about the agent that you can utilize with the service in order to pass metrics to NS1 to make decisions. We'll also talk a little bit about some use cases. I like to call them small, medium, and best of kind of how you can utilize both products to accomplish a routing strategy that is performant, modern, and able to accomplish all your goals. And then we'll also talk about any kind of next phases of the integration and pause for a bit to kind of talk about roadmap items and things like that. And then we'll wrap up with some Q&A. So hopefully we'll get you guys out of here with some time to spare and get all your questions answered. So to start, I think, and Damien, I think he has a little bit to say about this as well. But one of the reasons why I think we chose to kind of pursue this partnership is that, at least in my experience, NGINX is all over the board as a respected sort of software-defined load balancer in the space. I've used it in many jobs before this one, and kind of I'm familiar with a lot of the other things that, it can accomplish, such as being a content cache or web proxy. And it has all these really great pieces of functionality that I think are kind of table stakes for the space right now. And NS1 is sort of pursuing a more modern way to do DNS in the space and kind of providing a more software-defined approach, making DNS a little bit easier to understand and also easier to apply in an application delivery setting. Damien, I'm not sure if there's anything else you would want to add to that as far as, kind of us coming together and kind of bridging a lot of the pieces that make us kind of a good story to tell.
Yeah. I mean, as the landscape changes in the whole internet and how we deliver websites and services, and I mean, NGINX powers I think over half the internet now, and the whole idea of having a GSLB solution is getting more and more important and necessary for more people's infrastructure, and NS1 is really doing some really interesting stuff in the space, and we want to partner with as many providers who can add value to the customers' environments and really bring something new to the table, and I think NS1 does a great job of that.
Yeah, great. We're just doing great jobs all around. So to give you guys maybe a little bit more of a value driver kind of checklist of kind of what we're trying to accomplish here, we're really allowing you to kind of take control of an environment that, might not be as homogeneous anymore and is more heterogeneous in design of kind of having, resources maybe still in traditional data centers or colo facilities, but you're migrating to the cloud. With NS1, hybrid infrastructure is our jam, considering everything still has to speak DNS, and kind of increasing the performance and decision-making that we can apply with our filter chain. We're going to talk about that in a bit, kind of our proprietary software and how we apply those traffic management policies. And kind of also utilizing, NGINX is already probably in your stack in some regard, which is why you may be here today and why you maybe have heard about this webinar, really utilizing that as a tool to inform other things in your stack. Plug and play is a huge part of kind of what we like to do at NS1 is, figuring out what things are already in our customers' deployment models and kind of how we can utilize those to leverage, a better end-to-end policy that can be easily repeatable and applied for, again, modern application delivery. And I think that this is, just a natural fit. So if we talk about NS1 in general, I like to think of us being a very critical path product. I've been in the DNS space for a really long time. Damien knows this as well. I previously worked at OpenDNS and as an original employee, kind of learning the recursion space and working in security. And even then, I was kind of aware of what you're seeing on the screen now, which is the timeline of how DNS in general has not really pushed itself forward. It's more of a decentralized system than ever, of people trying to basically do what we can to keep things in place and working, and RFC and all these things are really important, but the modernization of how we need to deliver users the information that they need or the applications they need today, can't be reliant on something like bind or power DNS. And so you can see here that, back in 1983 in Berkeley, we have, the invention of DNS. That was something that got pushed, to the pre-2000s, didn't really change a whole bunch during, this explosion of kind of like networking technologies. A lot of people were still having issues with, things like root hents or, individual sort of clamp on technologies that were allowing sort of, certain functionality to work in some regard, but not in others. And then in the early 2000s, we sort of see this, sort of emergence of new managed providers in the space like Ultra, Newstar, Infoblox that are kind of providing managed services to the public and providing their version of bind or power DNS with a few features slapped on there to kind of make application delivery for the enterprise a little bit easier. But the thing is that, again, even in the late 2000s with like things like Dyn and Akamai, people are still based on this like technology from the 80s that is, rife with kind of vulnerabilities and a lot of things that are limiting in the space of kind of how we wanted to do that. And so what NS1 saw sort of in 2013 was the opportunity to create something that was entirely new and proprietary that wouldn't be limited by some of the traditional technologies that we know in the space to be true today. And so we kind of tout ourselves as sort of an intelligent DNS and traffic management platform that's all delivered via layer 3. And because we're software defined, we basically allow for full management of everything via an API, and everything is extremely lightweight. You can still utilize a hidden master. Things like that are still possible if you have, old technology that you're still getting rid of. And we're basically trying to be sort of as agnostic and kind of as performant as possible with what you have in your stack today. And that's sort of our goal with kind of what we're doing with NGINX and other partners. So whoops, went a little too fast. Sorry, go ahead, Damien.
Oh yeah, I was gonna say it's really great seeing people like NS1 doing these interesting things because you can just see, for however many years nobody was even thinking of DNS. It was just that thing that you had to run. You were just running bind somewhere, and for over 20 years, almost 30 years, people having basically the same thing that is the foundational building block of the internet. So it's really good to see some new headway being made in this space and kind of bringing things into this century, as it were.
Yeah, definitely. And I think for us, part of the thing is, being thought leaders in the space and kind of taking things to the next level. And there are others in the space that we work with as well that have similar mindsets that we hope to bring into, the future, or the now, as they say. So taking a look at our product portfolio really quickly, what we're going to focus on today is our managed DNS solution, which is what NGINX is going to be integrating with. We also have, a couple of other things that I just want to point out. Pulsar will also be mentioned in this presentation. It is our latency-based routing engine that utilizes anything from real user metrics to quality of experience data for streaming or even application delivery in general, for allowing us to do things like CDN negotiation or any kind of resource negotiation that you might need, and picking, the most performant endpoint depending on the time of request. And it's very helpful for a lot of our customers. We're doing, huge work with this in 2020 that you guys will be able to see very visibly pretty soon. Our dedicated DNS is basically just a multi-network solution to allow for redundancy, disaster recovery, a lot of, DDoS absorption, a lot of things that, we have sort of pushed forward in the space with the call for multi-provider support and still providing that end-to-end traffic management full capability in DNSSEC end-to-end signing. And then our China net is also a dedicated POP network within that part of the world, that if you're delivering an application there or any kind of resources, and you need something that's going to be performant and maybe have a little bit of traffic management piece there, and having the ability to deliver everything smoothly without any interruptions or any kind of need to traverse the Great Firewall, that's something that we can do as well. I'm actually calling you guys from KubeCon today in San Diego, which is where we're also talking about our private DNS and DDI products. We have an integration with Kubernetes that we're promoting here today, but all of these products are basically our managed DNS platform that has been containerized and allowed to be placed wherever you need it, whether that's a cloud repository or a VM in a physical store, and the ability to utilize DNS, DHCP, and IPAM. And that's sort of our future as we go into things. But today, let's talk about managed DNS. So the next phase of kind of what we're going to talk about in this webinar is really how to get started with the integration and how to utilize, maybe if you're an NGINX customer and you already have NGINX Plus, or maybe you're an NS1 customer and you want to learn more about NGINX Plus. This is going to kind of talk about how those two things come together in a little perfect little GSLB sandwich that we can kind of provide policy for. So what you're going to utilize to get started is basically a registered domain name is all you'll need, an NS1 managed DNS account with filter chains. We have a free sign up on our website if you guys are interested after this webinar, and you'll get information as well from us to basically be able to sign up and play around. And then, Damien, if you want to go over the NGINX pieces, yeah.
Yeah. Then basically, we always say you're going to need, 3+ NGINX Plus instances deployed, mainly just because you always want redundancy. Anything, 2 is kind of the bare minimum in my mind. And again, you need these configured with the NGINX Plus API enabled and exposed. This can either be exposed locally, or you can have a shared agent that are collecting from all of your nodes. And then for the node that you are running the NS1 agent on, it will need to have Go 1.7 or later installed, as the agent is written all in Go. And as well, you can also get a free trial license from the NGINX website as well, so you'll be able to stand up this whole example in your own environment if you'd like.
Which is so awesome, because you guys can just get started right after this webinar, which is great. So thank you for that. So, and just so you guys are aware, side note, NS1 also being 100% API based, we also have a Go SDK to fully automate the approach to managing your DNS as well. So you can have it end to end be Go and have it be extremely easy. So let's talk about our managed service. So what we really decided to do with our network design, and it was a deliberate choice of really deciding how we wanted to run our own DNS network and how we wanted performance to run. And I think what's, cornerstone to our business is performance, security, and, prioritizing cost and other metrics that you might have. All of those things kind of play into our network design and kind of how we thought about application delivery today. So we have an anycasted network that, has reach, capacity, and reliability, and has the ability to absorb DDoS attacks at any given point. That's part of, your our commitment to you as far as an SLA and a performant network. We have proprietary name server technology, again, that does not utilize bind, which is why we can utilize an API to update it. There isn't, another translation layer happening there. Our name server set can also ingest telemetry, which is what we're talking about today as we get into this NGINX. We get a little bit deeper into how the integration works. We have the ability to take things like load metrics and availability metrics and all of these readings of status to determine whether or not a particular location is performant enough, and either removing that answer from the rotation, whether that's an IP or a CNAME to an IP, or providing, the ability to, maybe ease off a certain amount of traffic based on active number of requests, which we'll get into in a bit. But other things that we do as well is, instant global change propagation. The long time on a bad day for NS1 for making a change to any kind of record via an API or the UI takes 2 seconds to propagate. It's extremely fast and performant. After this, if you choose to maybe go forward with NS1, a lot of our SEs will do a demo for you where we will dig and do that sort of propagation change live for you, so you can actually see that change time. Because, we feel that should be performant and should be immediate. You should not have to wait for a change window, and there should not be, lag for propagation time. We, have tons of redundancy in China-based use cases that allow for us to deliver in difficult parts of the world, in addition to latency-based routing for some of you doing application delivery at, an even higher scope. And then turnkey DNSSEC, this is huge for us. We are one of the only providers in the space that actually provides the ability to do online citing, which is extremely easy to implement, no more changing keys. And it allows us, allows you to kind of implement DNSSEC per ICANN, call of adoption a lot easier. And so how we do all of this, we have our network that's been deployed with a lot of the controls in place. And if you ever are interested in talking with NS1 a bit more about how we do that, we'd be happy to talk about our network design philosophy. But one of the ways in which we put forth these traffic management policies and how we're going to use all of that information from that NGINX Plus piece to influence us is with our filter chain. And what you can see here, and this is what I like to call it as most basic, is that it's infrastructure aware DNS routing. So really what we're doing is we're leveraging telemetry that's already being captured, again, by that NGINX Plus NS1 agent. And we can measure for anything like availability, bandwidth, capacity, or latency, depending on what metric that it is that you need. And we take those dynamic preferences and put them along static preferences to steer, right? We know what the update is to remove any kind of inactive or downed answers, but then we utilize things like cost or commit or priority to shift a certain number of traffic depending on what's left in the pool for an available answer. And you can have even things like an IP net fence prefix, which we'll get into in a minute. And the GeoIP database that we have has the ability to, get extremely granular in the United States, and globally we can get all the way down to the per country level. There's another sort of subdivision of information that's being added in Q1 for us that'll allow us to get even more granular with that information. And all the ECS information that we collect from your end users allows us the ability to either target or fence them depending on their location and where your resources are located. And so we identify them, have the ability to route them appropriately, and kind of capitalize on that a little bit. And so if we talk next about some of the other capabilities that the filter chain can go through, it has the ability to do all of these things in one chain. It's not just a single policy tenant. So what this allows you to do is to create sort of the ability to have, grouped answers in a certain region. If, for example, within the United States, you want to apply, a multi-region sort of policy here with multiple resources that might be across different types of infrastructure, and you want to maybe have a fallback answer if any of those become unavailable. And all of these can be stacked to create really powerful rule sets, no coding required. It's simply an API call or a really quick change in the GUI. It doesn't require any sort of JavaScript or anything to be coded into a server. It's extreme. And again, those changes propagate within 2 seconds. I would say that some of the things above a traditional GSLB solution that we can utilize are things like our sticky shuffle. What that allows us to do is to serve a particular end user one of the resources in your network that may be available at that given moment, and continually return them to that same resource every time they need to fetch any kind of content or data, which in application delivery strategy, that can be extremely important in cutting down things like lookup time and increasing performance. Even things like geo proximity, that gets changed with not just targeting, which most providers can do, but we can do fencing as well. So for things like GDPR, where you can only sort of surface a particular answer maybe within a certain geo region to a certain data center to allow them to process differently based on any kind of regulation. That is something that we can easily implement here as well, in addition to taking load metrics into account. And if we keep going, we have the ability to kind of take all of these rule sets. So we talked about sort of all of those rules, and I think that the best way that I like to describe them is really thinking about sorting, shuffling, or removing answers based, again, on those dynamic feeds that we're being given to, by NGINX or any of our other partners. And then those static preferences of commits or GeoIP database or, any of those other pieces that create a cohesive routing policy. And so if we talk about that first piece and how we get that integrated telemetry, and you can see on the right that there is a few answers that have availability monitors configured, which is simply like a health check. It's giving us a thumbs up or thumbs down if a particular answer is available. And we can see that, 2 out of the 3 answers, it looks like, we have maybe a cloud provider of choice, whether that's GCP or Azure or AWS or any other cloud store that you might be using. And then we have a traditional DC model on the bottom of, something that might be, in a colo facility somewhere that you still maybe haven't decommissioned, that are still, active and kind of running and are over provisioned to handle a lot of traffic. And between these, you have 2 answers that are available and 2 answers that are not. And we have all those geolocated for service, right? And so how we use that telemetry is in real time. Everything can be pushed on a frequency that you choose. The NGINX Plus integration is real time for any kind of read on any of the load metrics that we are receiving at that given point. And so all of the health checking and all that real time data ensures that we're basically able to reroute people that are sent, that might be sent to unavailable or overloaded resources without those health checks. And then just the last point that we see on the slide here is our eyeball measurements. This is with regard to our Pulsar service. We utilize JavaScript tags and other methodologies to basically measure real users at the edge that are requesting a particular application, and whatever service that responds, we have the ability to make that mapping based on where they're located in the ASN that they're on, to create a table that'll allow us to keep those measurements in mind with delivering the application and kind of providing the ability for us to make a decision based on network conditions, where the user is located, and the resources they're requesting. So
and the great thing when we're dealing with the NGINX integration too, as you can see, everything's kind of broken down by the different providers. So we're not looking at individual instances, and the same is possible with the NGINX integration, where you can have a single agent that is collecting from all of your NGINX Plus front ends in that given data center, that given physical location, and then feed this information back up. So you're not looking at pulling a single node out. You're looking at that location, on kind of more the big picture view. So you're doing the more intelligent routing to feeding all this information back in, so that not only are you looking at the physical location of these requests, but you can also see, based on the load, you can see how many active requests you actually have in that specific area. So you can do much more granular decision making by using all this telemetry that NS1 has in there, in conjunction with all of the extra information that NGINX can feed in here as well.
Definitely. And I think part of another point that you definitely brought up that I want to make is that a lot of people out there, if you're on this call and maybe you're still hosting your own DNS, or you're, not with a managed DNS provider today, putting, traditional, load balancer with the DNS service in the same, location, that has its sort of challenges in being able to, remain up, not having a particular, basically distributing your systems as much as possible is always best practice these days. And so allowing us to maybe see the viewpoint from NGINX, ingest that, while also, utilizing our network view to basically see what's happening, from, with regard to ASNs or anything that might be happening with BGP at that moment. We have the ability to utilize all of that to create a really, really rich traffic management policy. And so with this wealth of metadata that we have, we meet the shed load filter, which is what the NGINX integration utilizes from NS1 to put forth all of that data that Damien is talking about. So we have the ability to choose any of the following metrics to route based upon for what you're measuring with that agent. So that can be either active number of requests back to a particular POP or resource, active number of connections to that resource, or load average that's being monitored by that particular point of presence. And so we have the ability on the right, you can see that there are some metadata fields that we can fill in. The requests, load average, and connections are, again, that current read from whatever NGINX is sending us. The low and high watermark are kind of our goalposts of where you want minimum usage and maximum usage to lie. And so you have the ability, and again, these are static, they don't change. What does change is the active number of requests, the load average of the connections, and that changes in real time. But, whoops, sorry guys. Oh no, sorry, having some trouble today with PowerPoint, apologize. So the low and high watermarks are static and designed to basically say, okay, I want to send a minimum amount of traffic or at least have a minimum amount of load to this particular pop. For the high watermark, if we get near that and we notice that, NGINX is sending us a status that is near that ceiling, we will edge off and potentially take that answer out of rotation until we reach a certain happy medium between both of those. Again, that's permissible. And the cool thing about this is that, again, having the API, you have the ability to send a quick call to update either of these low or high watermarks based on, particular release or anything that you might need to change for. And that can, again, be updated in a couple of seconds if needed.
Yeah, and it's really great with these, the requests and these load average, being able to leverage the NGINX Plus extended API and all the extra metrics we expose. You're actually able to do this in very granular ways. So you can look at requests globally. You can look at requests to a specific server name. You can even look at requests as specific as requests to a specific location block, or even requests that are being routed to your upstream application server. So again, we just really are trying to provide you as much information so that you can tailor it and really pick the metric that makes the most sense for your specific environment. Because I've yet to encounter two environments that are the same in this space.
Definitely, I completely agree. And having the option to kind of route what's important to you is really important. And there's also ways to this can be customized on a per record basis for NS1. So whether that's an A record or a C name that you have these applied to, in certain data centers or certain locations, or even certain services and applications, you might have a different metric on a per, resource basis. And this allows you to kind of customize that on, per record basis, which is really nice. Cool. So let's talk about how we install the actual NGINX Plus agent and how we utilize that.
Yeah, so the agent, like I mentioned before, it's very simple Go agent. Basically, what it's doing is it's just going to be collecting data from either a single NGINX instance, or you can have a whole cluster. So it kind of, again, depends on what makes the most sense in your environment. So you can have a single node that is sitting there and collecting information from all of your NGINX Plus front end nodes in a specific data center and sending that in as one lump value. That usually would then have another load balancer in front of it acting as the ingress point to that architecture, or you can have it running on an individual per node basis and actually be shipping that specific information for that single NGINX instance to NS1. So again, it very much just depends on what your needs are in your environment. Again, we were saying the active connections, and that can be as much as on a global scale, that can be on a per server name, a per host. There's a lot of granularity you can get into and to make those decisions. So, and again, like I said, it's very basic. You can see here we got a little example configuration file. In this specific use case, you can see there's the host is set to 127.0.0.1 on port 8000. So this would be for a local instance. Again, if you had wanted to be collecting information from multiple nodes, you would just list multiple hosts in that field as, I believe, a comma separated, as a comma separated list. And then you just, configuring a couple other things. You're configuring the interval time, retry time. Again, these are all can be finely tuned to your environment. Little things like where do you have the API endpoint available to, what timeout you want. Then obviously you have a little bit information about your account at NS1, so an API key so we can authenticate with their system using that Go SDK that Monica mentioned earlier. Again, another timeout variable you can set. And then again, a source ID, so that piece of information that links this to the correct records in the NS1 system. And then down here, you can see that the services are defined. So this is kind of looking at where you're going to get the information from. So this one is pulling the statistics from the upstream group. So it's looking at how many connections are being routed to the application behind NGINX. This can also be based on the server name connections and things like that. So again, very configurable. And then all this data will just get shipped up to the NS1 system. And then from there, all the magic happens and the decisions are made.
Awesome. Super, super easy. We pasted the code next to the actual on the slide just to show you how easy it is. Just pass in some variables and you're all set. And awesome. So let's talk a little bit about how the filter chain works in practice. We've talked a lot about theory, probably wondering, well, how does this really work? And kind of talking about a little bit of, sort of a basic, intermediate, and then advanced with NGINX and everything coming together in just a nice, sort of great, reliable and resilient policy that you can kind of put forth time and again on anything else. So we have first our example, easy.nginx.com, which is an A record just with some IP addresses that we're forwarding to, and you can see those on the right. You can see our users on the left are on different networks in different locations that are making requests to this record. Now, the filter chain below, and you guys can see that, hopefully. The text is a little small, apologies. So you can see that we have two rule sets or rules on this chain, and everything applies in a top-down execution style. And to revisit the concept that we were talking about earlier, we are really just sorting, shuffling, or removing answers. And so based on, that logic, you can see that we are shuffling answers around. And so this is what most people would refer to in a traditional sense as a round robin. So essentially everything that reads as a valid answer on this record is going to be distributed evenly according to how many users are requesting that. And they're going to receive an answer without any rhyme or reason. Select first n is simply just our rule that allows us to limit the number of answers on a particular record to one. You have the ability to specify up to 50 answers on any NS1 record that you have configured, an A record or a C name. So this just allows us, if your pool is that large, if you do have that many resources, if you're multi-region with a ton of different, pieces and, cloud providers or colos, we keep talking about hybrid, if you have resources that are kind of distributed very widely in a particular location, you have the ability to specify all those and kind of set up a policy based on groups. But in a very simple sense, this is probably the easiest chain that you could come up with. Putting this together takes 1 minute and 45 seconds. That's all it takes to kind of configure the IPs, throw everything in there, and you're good to go. And again, that's via the API or the UI. So let's take another step further and talk maybe a little bit more about something slightly more complicated. So we have medium.nginx2019.com. This is a C name. This is just, referring us to the particular record that has that IP address that we're trying to eventually get to. So what this is doing, we can see again, same concept on this slide. On the left, we have our users on different ISPs and our, location and possible answers on the right. And we can see that those are all located in different locations as well, but they're all more or less distributed between 3 geo regions: North America, EMEA, and then South America or LATAM. So we can see that there are 2 answers that are possible within those regions. And on the left, we have users from a variety of different locations. And what the chain is doing at the bottom is we're simply doing a really simple geo-targeting policy. So what geo-targeting is basically doing, we're utilizing the eDNS client subnet information of the requester. If you're utilizing a recursive resolver like OpenDNS or Google, you do have the ability to pass on your details as part of that query to the authoritative name server and retrieving that answer. And so we'll get an even more granular look into where you're coming from. But even if you're using your ISP's DNS today, or your end users are, I know most of you on here are probably just a little bit smarter and wanting to choose your provider, but if your end users are, say, on Verizon, on Comcast, on Vivo, whatever that might be, they're still targeted within that appropriate region, and we're able to route them based on that ability. So once we target them to either, close enough to North America, EMEA, or LATAM, we're also going to set a priority. So each of the answers on the right are set with a priority that have the ability to, say, maybe prefer the more over-provisioned data center over the other. And this is a static preference. This isn't being informed by anything. This is simply just, I want to, in North America, prefer the Ashburn data center simply because it's our original, it's beefed up, it has a lot more capacity, it can absorb, any kind of, DDoS or traffic that might be sent, or, any kind of, ability, during a launch to, serve as, a very sort of centralized data center. It has the ability across each of these. And if there's a preference for one or the other, in this diagram, we have a preference for Ashburn, London, and Sao Paulo. We can have the other answer be preferred less often, but it can still be part of the rotation. And so this is a way in which we can statically set a really simple policy while utilizing ECS information that NS1 is already privy to without you needing to integrate anything, right? So this is great, but we can do better. Like, we can do a lot better, and we can do a lot better with NGINX. So we're going to go to sort of the piece de resistance of what we're kind of building up to here. And this is using the NGINX Plus clusters to inform us, and also utilizing our Pulsar engine to make decisions based on performance. So what we have in the chain here, and again, same setup on the left and the right, is the up filter, which is, again, checking for availability. So that's something that you can do with our built-in monitoring system, which we provide as part of the service. Or you can utilize something like Catchpoint or New Relic or Datadog or anything that you're using in your stack today to determine availability of a resource to give us that thumbs up, thumbs down initially. And so what we do is remove all the down dancers. Shed load is where NGINX comes in. And so either those active number of connections, active number of requests, or active or load average. All of those different metrics can play into how we're routing customers to those locations on the right. And then once we determine what is available based on that and based on those low and high watermarks, we'll go to our Pulsar sort filter. And this has the ability to utilize, again, quality of experience data, RUM metrics, anything that's happening at the edge that we can see between all these different end users that are requesting your application in real time. And we can say, okay, these answers on the right are left, and this CNAME is going to forward to, a number of CDNs, whether that be Akamai or Fastly or Cloudflare or Edgecast. And let's say that, in this particular region, we have, again, the split out of North America, EMEA, and LATAM. We can say, okay, between all of these, in North America, Fastly is doing well, in EMEA, Akamai is doing well, and in LATAM, Cloudflare is doing well. And that's all based on current network conditions that we can map utilizing a geo and ASN mapping, and all of those users at the edge kind of making requests to any of those individual resources. And so the latency-based routing is a huge part of our strategy, and it's what you can utilize with those load metrics to say, okay, we have all these pieces, all of these components, are there. We can kind of follow all of these individual components down the chain to kind of create a multi-resource, cohesive strategy to kind of put forth to the end user. I think that this could be even more simplified with the NGINX integration. We wanted to show you kind of something that is a little more, above and beyond what we can do. But even with NGINX in the mix, as long as we have some of the static preferences to validate and kind of perfect upon all of the metrics that we're receiving from NGINX, we have the ability to kind of create a very automated, easy to use, and performant policy. Would you add anything, Damien?
Yeah, I was just going to say, and I think this is really where this integration becomes so powerful, because, you can see all of the intelligent routing decisions that NS1 can make, and then also all the pieces and the extra information that NGINX Plus can add. But no single metric on its own is the correct solution. It's all about having this combination of information. So you're looking at the biggest picture, and just because something is physically closer to the end user doesn't mean it's the fastest for the end user. And just because maybe there's a data center that's completely unloaded and NGINX isn't doing anything, but the connection to that data center is having issues. So you never want to make a decision on just one of these pieces of information. The powerful part is putting them all together and using all that data to make the most intelligent decision you can.
Definitely. And I think one of the things that we talked about, we kind of got on about it in Seattle, which I kind of laugh about it when I think about it now, but geolocation is not necessarily always the best way to determine the most performant resource, right? This is the way to do that. In having a multi-tiered policy that's bandwidth and connectivity aware, that takes into account not just your resources, but the resources that are available that are internet delivered, right? That you don't have any control over. One of the biggest things that I talk about with our customers every day is kind of, how do we ensure performance from, a certain type of cloud provider, or how do we ensure, that BGP isn't going to take us down by doing incorrect network mapping, and all of those things, unfortunately, because we're part of a decentralized system, kind of have the ability to play into, some of the errors that we encounter on a daily basis with routing. And so this allows you to kind of take it into your own hands and kind of, be a little more proactive and automated about your approach to kind of what you're going to do here. So
exactly. I mean, your connection traverses so many different companies' pipes to actually get from your computer to the data center that may be physically closest. Yeah, having that overall viewpoint is so beneficial for that sort of scenario when you don't know if somebody they may be down the street, but maybe they're using a cell connection and their cell signals getting bounced all over the place, and they have all these different places to traverse. It's having all that information is so powerful with this sort of decision making skill.
Definitely. I think part of, what we have to offer, at least both of our products have to offer, is just the idea that it maintains a modicum of control in a very chaotic environment, and kind of eliminating the amount of hops that you might have to make to, get all that information that you might need, which is really important. A lot of the things that we were seeing in that chain can be accomplished by 5 different products in the same stack. But again, utilizing 5 products versus 2 requires more hops, adds on latency, impacts performance. Your end users aren't happy, and that's what we're trying to avoid, I think.
And your engineers aren't happy maintaining so many different products. So.
Oh, good Lord, yeah. I wish you could all be on a fly on the wall at KubeCon right now. Everyone is asking how they can accomplish everything with one product, and eventually we'll get there. But at the moment, all of these things are extremely complicated, and we're trying to make life easier for you. So I think some benefits that you can use, we kind of just talked about this, but I mean, health checking is extremely important. You want to be able to, direct your own show and with regard to your resources and know versus, reacting to a situation. You want to be proactive and have NGINX inform us of kind of where those capacities lie and kind of how we can direct your traffic appropriately. Central capacity planning is really important. You want to be able to maintain balance amongst particularly, intense network event. If something, you're doing a launch, something's going wrong, you want to be able to kind of restructure a policy by sending a quick API call, or again, just automatically shifting that based on the filter chain that you have set up. Manual failover, and we did get in on this in Seattle as well, is not a way to live your life. There should not be any kind of manual, change windows or anything that you need to do with DNS in 2019 and going into 2020. We want to avoid this at all costs. The thing is, it's human error, and it has the ability to, depending on who might be on staff at that moment, having to do that and however much information they know, can lead to a disaster really quickly and make things a lot worse than they already are. And it shouldn't be relied on when there's sort of that unexpected shift, right? And whether that's, again, network-based or based on, what your particular data centers are doing, that gets really difficult in trying to predict and trying to control. And so having something automated in place can take the guesswork out of a lot of what this is trying to accomplish. Cool. And so, yeah, if we talk about key takeaways, I think the thing that I want you guys to walk away with today is that doing this at layer 3 is something that a lot of people are starting to adopt because of the performant nature of it and our ability to kind of, again, steer and automate traffic delivery with an API, at the DNS layer, is something that, I think a lot more people are starting to adopt, and kind of being able to take a multi-layered approach and being able to kind of keep in mind a lot of, what their static preferences are, but again, being informed by products like NGINX that are so powerful and so prevalent in this space, and allowing us to kind of fit into your stack in a way where, you definitely need DNS externally. Let us do it a better job for you, and create sort of an infrastructure-aware approach. And Damien, would you add anything to that?
Yeah, I mean, I think you did a great job covering it there. And, in my mind, the important thing here is automation and, have systems in place to deal with this. So you don't have, some admin waking up at 3 o'clock in the morning because their phone just went off because something broke, and now they're doing guesswork to make the right decision when, you can leverage all these tools that are out there to help automate this process, and have that intelligent decision made no matter how little sleep your guys have got.
definitely. All right. So then we have sort of a few things. We got F5 on here as well. NGINX is now recently joined with F5, so they're all part of the family. Those are all people that we can work with. These are all some of our partners in the community. This is growing every day. The slide is going to change by the end of this month, which is going to be crazy. So anything you have in your stack, we can probably work with them, talk to us about it. We love doing this. And these are just a few of the people that trust us with their DNS. There are many more that we can't put on the slide that we could tell you about, in sort of, scrub terms, but we can kind of talk to you about their use cases and kind of how they're utilizing NS1 today. So I think we can maybe go to the question portion if we're ready.
Yeah, we got one question in.
Sure. Wow, we did a really good job. 15 minutes.
Yeah, is Sticky Shuffle based on EDNS client subnet?
That is correct. So we take that information with routing our users, anybody that's making a request to an NS1, maintained domain that has a filter chain policy on it. That GeoIP database is part of how we do the geo, but as far as the Sticky Shuffle, we memorize the IP address from wherever that user is initially coming from, and that's held, as part of, that person's policy, and we have the ability to deliver that person continually to the same resource to cut down on that delivery time. So yes, we do use that information to accomplish that.
Great. The second question, can the NGINX NS1 integration work with open source NGINX?
Currently the integration is built specifically for the extended status API that is in NGINX Plus. We are looking at extending it to open source, but there are some issues with the way that the metrics are expressed in open source versus Plus. So hopefully in a newer version of open source, we will be able to make this all work, but it is something we're looking at, but it is not currently available.
Great. We'll just wait a couple more seconds for any more questions. If you have any questions, you can enter them in the questions panel if you go to a webinar window. So it looks like that's all the question. Oh, one more. What is the HA on NS1 DNS as a service?
The HA on NS, okay, so if we kind of talk about, our SLA is 100% as far as delivery is concerned. It is an anycasted network, so we have the ability to deliver from 25 POPs globally. The high availability portion, can be configured between your resources to, have, say, an answer and a backup answer. But as far as the deliverability of our network, because we're anycast, we basically never stop responding to queries as a service, which can be, detrimental. Obviously, serving an NX domain to one of your users would be a very bad day, as it were. So we take that kind of performance very seriously. It's part of our network design. But as far as HA is concerned, we can configure multiple answers to kind of have that approach to allowing your users to, again, cycle between multiple answers on a particular record, and, the performance of our network, has the ability to cycle through different data centers if needed to kind of deliver the information that's being requested.
Great. All right, last call for any other questions before we finish out the webinar. Give it a couple more seconds. All right, it looks like that's it for the questions, Monica.
All right, awesome. Well, I would like to thank Damien and the NGINX team for having me on today. It has been such a pleasure working with you guys over the course of the past year. And I'm extremely excited to see, how this kind of shapes up for open source and any other things that we might do together. So thank you guys so much. Appreciate it.
Yeah, and thank you for joining us for this webinar, everyone, and especially Monica. And yeah, we look forward to working more with NS1 in the future.
Great, thanks you too. And the webinar video and the slides will be made available shortly after we conclude. Thank you everyone for joining us, and have a great day.